in case someone was confused, because there were some people that they were coming for the session at 7 in the same room. So this is Tram, and we're going to get started in a minute. Okay, so let's get started. We have the presenter already. So welcome to the Tram session. As I said, this is Tram. We will be running until 7, and then after 7, we will have another session. So please note the note well. If you are not familiar with that, please go and read the RFCs actually referenced in that note. First, the logistics. We need a minute taker. Anyone can take notes? We need a volunteer, please. Okay, thank you. We need just like high-level decisions and roughly what happened, and then I'll edit them out into the minutes. So thank you. JavaScript, Ule can do it. Thanks a lot. And then the meeting materials, if you go to the webpage, I have uploaded all slides, so you can find everything there and the agenda. And the mailing list, you know where to send emails to. So this is the agenda. We're going to have Gonzalo or Mark. Okay, Mark presenting Stambis, the open issues, just to move forward. And then we will have a presentation also on the operator-assisted relay service architecture to conclude the meeting. So let me go real quick over the status of all the drafts. Actually, I mean, we are doing quite well with the working group. We are advancing quite well. So let's try to keep the momentum. So we have Stan Origin. As you know, we were discussing that a few IETFs ago, and it seems that it hasn't been revised. So probably we don't expect any revival, but that's where things stand at this point. We have stand path data, which was reviewed after I mean, the ISG basically reviewed the draft. It was revised, and basically now it's just waiting on Spencer to approve it. So I see Spencer at the end of the room. So I see in the tracker that all the discussions have been cleared, and you have a few yeses, a few no objections. So probably it's just waiting for you to I mean, request the approval. So, I mean, no rush, but just, whenever you get to it, that'd be great. Then we have turn server discovery. So as you saw, all the open issues were closed. So we have requested the publication, and now is actually Spencer is doing his AD review, and he's having a conversation with the authors. Then we have Stambis. Today, Mark is going to be presenting that. So the idea is to start a working group last call quite soon. And then Term-based is depending on Stambis. So basically, the authors are actually checking whether some of the changes in Stambis will basically mean also changes in Term-based. And the idea is also to working group, let's call it, fairly soon. And then we have basically asked for volunteers to review the last draft. And Ram already volunteered. If we could get another dedicated reviewer, that would be really great. Anyone could commit to a review? Thank you, Spencer. Excellent. The second draft that has become a working group item. So IETF, Tram, Stan, PM, TUD.
I'll Stan-based crypto sections.
Sorry?
I'll review the stun-based draft, the crypto reviewer. They were looking for a crypto reviewer, right? Security reviewer. The previous stun-based draft also needed a reviewer. I'll review that draft.
So you will review that draft instead or as well?
I'll review that draft.
So you will not review this draft?
No.
Okay. Okay, so we don't have any volunteers to review the draft? Yeah, well, I mean, like, now we're not going to present the draft again because we have done already that. But okay, I will take it to the list because, I mean, like having a working group item means that, you know, the working group is basically willing to work on it. And we need really people to put cycles on it. So we'll basically, you know, be taking this to the list and getting volunteers. I mean, this is something that Mark has talked about several times in the past as well, that, I mean, you know, the working group is not only about, you know, having your draft advanced, it's really about a community effort, and we need people to do community service, if you want to call it as well. So in that sense, I'm really expecting people to think about that and at some point be able to review the draft. Mark? That doesn't seem to work. Maybe you can take the other one or this one if you want. Or that one?
Hello? Yeah.
Yeah.
Oh, okay, so if someone volunteered to review this draft or stun, you get a review from me for your draft. Okay? So.
Hey, how's that? No, Justin is not in the room, I think.
He was interested in this draft, so maybe.
Okay, Gonzalo is saying that Justin was interested in the draft, so maybe he wants to review it. Yeah. Okay, so we will take it to the list, as I said. And then the Tram mobility draft, we also, working group last called it. So basically, now we requested the publication. It's in the same state. Spencer is doing his AD review and talking with the authors. So that much about the... Okay. Excellent. Thank you. Thank you, Spencer. So as you see, basically, I mean, we are advancing the working group items. We need to just advance the few that, you know, we need to working group last call, and we'll be doing okay. So Mark, you want to drive that from your laptop or me to do that? Okay, I'll do that. Yeah, it wasn't F5. What was it?
It was there in the menu, the view menu.
Okay. Because the shortcut wasn't...
Control L.
Control L. Yeah, exactly. Yeah, it's Control L. Okay.
All right.
Your laptop is blocking the corner of the screen. That one.
Okay.
No, the other laptop.
The other. Okay. Yeah, go ahead.
All right, next slide, please. Okay, so StunBase is now, from our point of view, feature complete. We added everything we can think of inside. So we filled the sections that list all the modifications since RFC 5389, which is here. There was one which was missing in the document. It will be the next version. So just to quickly a reminder of everything we did in this draft. So we kind of merge DTLS over UDP. We merge stun URI. We updated for the new RTO calculation in RFC 6298. We updated the precise things to RFC 7613. We fixed some bug. We updated the Cypher suite for TLS. This was one of the big modifications. We switched from SHA-1 to SHA-256. And we did a lot of other things that I will talk about because this is new. The sharing announce is no longer permitted. We added the possibility of using a domain name in the alternate server mechanism. We added some C code at the end to help because this Either thing is not easy, and we'll talk about the test vector. So next slide. Okay, so this is the modification since Stun bis 04 that we presented in Dallas, I think. So this is only the new stuff since the last presentation. So we will go through the user hatch support. We change the bit done attack protection. So we will not talk about this, but we removed, so nobody was interested. So we went to the working group which was doing a modification of HTTPOs. They were not interested of adding salted SHA-256, so we removed it from the draft. We added MD5 in the password algorithm registry for various reasons, not to support it, but because we needed it in the registry. And as I said, we updated the change list. So we will go now through the other modification next. Thank you. So this was something that we discovered when we worked with the people from HTTPOs. It was a nice feature, which was to hide the username when obviously the stun is not running over DTLS. So we decided to add the exact same features inside stun. So the idea is that we have a new attribute, which is called user hash. You hash, instead of sending a username, you send a user hash, and you send inside a hash of your password. This is as simple, well, not as simple as this, but this is basically this. So we made some choice here. We use only SHA-256. And we do not encode the resulting hash. We send it in binary, because if we encode in X, we now have a password which is 64 byte long. And if we use base 64, we have 48 bytes. So it's the most efficient way to transfer this. Any comment, question on this? Okay. So now we had another problem, is that if you remember the draft, we added for the choice of the password algorithm, we added a mechanism to protect against bit-done attack. And the way it's done is that we added a special prefix to the nonce that signal that a password algorithm was added by the server back to the client. So the client knows, or the server later knows that an attacker in the middle removed an attribute. The problem now is that we have a second feature that we need to protect. So one solution would have been to create yet another cookie value, but this time we need 3, right? We need password algorithm alone, we need user hash alone, and we need user hash and password algorithm alone. And then if in the future we want to have another security feature that we want to protect against bit-done attacks, then we need 7 different cookies and so on. So it's not very practical. There is another reason also, is that all of this makes the document, would have made the document really, really difficult to write first for us and to read, because it will be very confusing with all these things. So one of the things we did is that we created a registry for security features that need to be protected from bit-done attack. And we added, we allocated 24-bit bitmap for each of these features, which is put between the cookie that we call the nonce cookie and the nonce itself. So because it's base 64 encoded, it takes exactly 4 characters. So this has yet and we created, so let's say this, but we created a registry, which is a new IANA registry, where people in the future can add more features. This made the text far more easier to write, and we hope far more easier to read and review. So as I said, we have 2 bits allocated from this registry. Any question or comment?
Jonathan, thanks. So how exactly does this protect from bid down?
Sorry?
How does this protect from bid down?
Well, when the problem is that user hash is supported or not supported by the server, right? So the server, if the server supports user hash, it sets this bit in the nonce, which serve at the same time as an indication that the server supports user hash, and because it's in the nonce, it cannot be removed by an attacker in the middle.
I see. So it's okay. So the point being that the client, when the client receives it, if that bit is set, he you know, but the other relevant attributes aren't there, he rejects it, right?
Well, so if the client supported, then it will use user hash and then use the nonce with the same value because it cannot.
So is there
change it.
What is a client supposed to do if it receives a hash with a bit set it doesn't know about?
Well, you just ignore it.
That's safe. That's not.
Yes.
Okay, as long as, but if it's a bit that it does know about, but the attributes aren't there, it should reject. But if it's a bit that doesn't know about, then
if it doesn't know about it, it's just like it do not implement the features.
okay.
So
Yeah, I just want to make sure that there isn't.
As long as it's sent back.
Explicitly called out.
If it's as long as it's sent back the same nonce, the server knows that the client that it was not ignored by the client. It was just not known. All right, next slide, please. Okay, so this was a proposal that was made, I believe, by the people from ICE, which was to have a way to shorten the value of the hash mark inside the message integrity 256 attribute. So we think that this is something that each stun usage should decide for themselves. I mean, Tram probably doesn't need to shorten this. ICE probably need a shorter hash mark. So we think that it's good to put some consideration inside this draft, so that can be followed by other usage, right? So there was 3 things that. Well, there is also the fact that we need to decide if we truncate by the right or we truncate by the left, right? So we need to be sure that everybody is doing it the same way. So it's a good thing that we put it in this draft. So the 3 things that can be chosen is the side. So we decide, I don't even remember if it's the right or the left, but it doesn't matter. In fact, it doesn't change the properties. The length, what is the minimum length that any usage can use? We can say, okay, you cannot truncate below 20 bits, 20 bytes, or 16. I don't know. And this is why we need a crypto review, by the way. And the other one, which I put in the first version, was the boundary. Do we do by 4-bit, 2-bit, and so on? And after this, I thought that it was not needed because even if we reduce by 2 bits, because of the padding, it will not change this. So this is always by a multiple of 4 bits. Yes? 4 bytes, sorry. Yeah, 4 bits doesn't make sense.
This was discussed in co-op sometime back, and for they're also using 256, and it was decided that 120 bit will be the maximum truncation size, nothing below that to avoid collisions.
I'm sorry, you have to speak louder. I cannot hear.
So co-op protocol also was using short 256, and because of the message size, it was decided that the maximum truncation would be allowed would be 120 bits. So if you can look into the co-op RFC, it already says 120 bit is the allowed limit. So you can just pick that and proceed. You
Okay.
already have an existing RFC which does that.
Okay,
He's saying co-op. and then-
co-op is doing the same. Yeah.
Yeah.
120 bits.
Yeah, they're using 120.
Okay, so we can align. So was some kind of crypto expert saying it's fine?
Yeah, it was
This is my only concern. We have text that said we have absolutely no idea
yeah, that
what
was
we are doing.
discussed, and that size was picked. So you can it's I don't remember, it was a long time back. It's-
Okay, so we can align on the same.
Sure, I'll send that section to the list. Can you go back to your previous slide, please? So if there is a man-in-middle attack who is trying to remove this feature, user hash feature from the server, and the client decides to use the regular username, how is the bit-down attack protected? I didn't get that. Could you explain what if there is a man-in-middle device who is seeing the response from the server and it just strips off these new features, and the client continues to send the same username without anonymizing it? So the client devices could still be compromised with respect to privacy.
So the way it works first, it's only for long-term authentication, right? We don't care about short-term authentication. So what happened is that this is a three-phase thing. So the server sends a bit that said we support user hash, but this bit is set inside the nonce. This is a very important part. This is inside the nonce. Okay. The client case one, everything works fine. The client receives this and supports these features. It sends a user hash and it sends the nonce. He has to send the nonce for the authentication. Everything works fine. Second case, the server sends the bits. The client does not support user hash. It still send a username, and it still sends the same nonce with the bit set to 1. Okay, so everything works fine. Now we have an attacker in the middle. The server sets the bits. The client see the bits which is in the nonce, right? No, so the attacker in the middle changed the nonce. He has no other way to influence the client than to change the nonce. The client has no idea that the nonce was changed, so it sent a username and it sent the same nonce which was modified. Then the server receives this and detects that the nonce was changed. And it can verify this because there is this time a signature on the thing that was sent in the other direction. So the client can. Sorry?
Jonathan, the signature will be right, but the point is the nonce won't match the
Yes.
nonce he sent. So you can verify that either by remembering the nonce or by having the nonce with some secret info on it.
Yeah.
Which he's signed. So he has to validate the nonce he received, which is the nonce he sent, but it's true in general purposes.
Yes. And this is the same mechanism that we used for the password, to choose the password algorithm. It's a little bit more complex because in this case, the server send a list of password and the client need to send back the choice, the password algorithm which was chosen, and it need to send also the list, the complete list that was sent originally by the server. So we are sure that it has the whole choice. And again, the nonce protects this.
Yeah, but the client is not able to use the security feature that the server is giving of anonymizing the username, right? So what is the incentive for an attacker to do this? Because he would like to learn the username of the client, right? So how is that attack being prevented? Yeah, server is going to reject the authentication and say that, hey, I'm not going to authenticate you because the nonce doesn't match or the signature doesn't match, and it just throws an error or just drops the stun request with the username. But the attacker has succeeded in his attack by making sure the client reveals his username to the attacker who is sniffing the traffic on the wire.
Yeah, right.
John, thanks. I mean, by the same point, I mean, if the attacker completely impersonates the server, you get him to reveal the username.
Right.
Yeah.
So, I mean, by just forwarding a response with that they didn't have this bit set at all. So, I mean, I'm not sure how. I mean, it seems like that same issue would occur with HTTP auth. So I'm not sure how they handle it.
Oh, they have no bit done protection on HTTP also. Yeah, we are slightly better.
Yeah, maybe if you could remove this, I don't. If it's not giving real protection, then why do it in the first place?
Jonathan, so I mean, you still need an indication that the server supports HTTP auth and putting the nonce as good as anywhere else. The bit needs to be somewhere, and that the server understands this mechanism. And so I don't know if there's any. I mean, obviously, if we didn't care about bit time, we put it in an attribute, but 601, I think.
John, what was the issue? I didn't get why. Why it doesn't protect you from?
So sorry. So the issue, what the initial thing was.
Yeah, I just didn't get it.
So the attack they're worried about is the attacker forces the user to reveal its username, right? So if the attacker forges a response from the server, for the first handshake, which is unauthenticated, he put in whatever it is he wants, saying, yes, please send me your username and also your social security number if you're so inclined. So, obviously that authentication won't ultimately work, but that attacker doesn't care, he's already got the information.
What? So, anybody has a better idea how to protect this?
DTLS.
Well, right.
Yeah, as for DTLS.
So, you mean that if we really want to to hide the username, DTLS is the only solution?
I mean, user hash is clearly valuable against passive attackers, which I think are probably going to be much more common. And it needs to be a mechanism by which the server indicates that it supports user hash, because it depends on the format of the password database, when possible. So, I mean, is putting it in the nonce. I mean, given the discussion we just had, I'm not sure how much benefit there is to putting in the nonce rather than an attribute, but I think there's maybe some level of benefit that, at least it's clear, this is maybe reveal the username, but if they can't, secretly reveal the username, there's going to be a, hey, why did my auth fail, auditability, so.
So it's better than nothing.
It's better than nothing, yeah.
Well, remember, we still have a bit done attack on the message and integrity thing. So it's not like we are completely. Well, the story is let's change as soon as possible to another version that deprecate completely message and integrity. So we still have a window where, but we have no other choice, right? So I see 3 things we can do. We can keep things as they are, and we use the bit as it is to signal that the server support user hash, and we can add some text in the security consideration saying, well, you can still discover the name. If you really do not want this, you have to use DTLS, first solution. Second solution, we remove completely user hash, because if someone really wants to be to have privacy and use DTLS, or we can remove it from the nonce and add an attribute that said that we support user hash. So we really would like to finish this draft. So if a decision would be made, we will send a revision tomorrow. We really want to finish this.
So who cares about this particular issue? Because everybody's checking email, and I mean, if it's only between Jonathan and you. Okay.
I'm happy to leave it as it is.
Okay. So Jonathan is saying he would be happy to leave it as it is.
I mean, I'm happy. I think with a little bit more wording and security considerations, saying, this is, that yes, this attack could happen from an active attacker, but it's auditable, and hopefully you can figure out what happened. But other than that, leave it as it is.
Okay.
So leave it as it is and not with this addition that is better than nothing.
No. I mean, Jonathan, I assume the thing you're talking about here is what's in the draft today, right?
Yes.
You leave the mechanism that's in the draft today.
Oh, okay.
With having the bid and the hash, but add some stuff, text and security considerations saying an active attacker can force the username reveal, but there'll be a auditability.
I am fine with this. Yeah.
Okay.
Perfect.
I thought you were going to go back to.
No.
Any other input? Okay, good.
Yeah. So we already talked about this.
This one?
Yes, this one.
Yeah.
Thank you. So, in the spirit of RFC 5769, we provided a test vector for SHA-256, and as an example, we added the user hash and the nonce, so people can see. People who implement standard by reading the example can use it. You should not. Please note that the example is not correct currently, because we don't have the code point from user hash and MI256. So it will be updated as soon IANA is sending us, which we should probably ask soon to have the code point to have at least the encoding correct.
Mm-hmm.
Anyway, an alternative is just to remove user hash and the nonce. We'll use non-modified nonce. In this case, I can provide a test vector which is working today. It depends if people are already implementing this or if it can wait. I don't know. Someone has an opinion on this. The alternative is to ask IANA to do an allocation sooner than this. Nobody cares? All right, let's keep it as it is.
Let's just finish the draft and the allocation.
Yes.
So, you could also just ask for it early and then we update the.
Yeah.
and all that.
It's a program that generates this, so just plugging the right number in it. So, next slide, please. So yes, so for our point of view, it's done. Thank you for the reviewer we had, Jonathan and Brandon. Thank you very much for your reviews. We probably need more now. We expect more. And as I said, for each review, I will owe you one on your draft. So, questions, comments?
So to be clear, I mean, this is to be ready for working group last call. So we will get dedicated reviewers there.
Yeah.
I'm not sure you actually mentioned all the changes that happened as a result of my comments, which I think was since Dallas, which was you mentioned adding MD5 to the registry, but also the fact that you can actually still say, yeah, I support SunBIS, but my password database is still an MD5.
Yes. So yeah, I didn't have a full slide. If you go back on my second slide, I think.
Yeah, you said.
Second slide, I said we
This one.
re-added MD5, which is in slot 1 in code point 1. Yes. So because it was a little bit complex, so I didn't want to.
I mean,
The change log has.
okay, yes, change like that. So basically, the point I wanted to give, this means that you can upgrade the disk without needing to, if your database has hashes of MD5, you can keep using that with the new support, and then gradually, as people change their passwords, transition to SHA-256.
Yes. Yeah. So our
So far, the single biggest pain in the ass
so our only open issue was the truncation. Now that we have an answer, that we are closing things.
So is there negotiation of SHA-256 and the message integrity where is there a
is-
negotiation between the client and server to pick the?
There is no negotiation. So what we do is that, okay, I have to remember now this very complex thing. So a new server and a new server always send SHA-1 and SHA-256. And then the client respond depending on what it understands. So there is an order. Some attributes are automatically ignored when they are after. There is a very specific order to put the attribute. So this is why it works.
My question is more with regard to the long-term authentication where the server is going to throw in error, so it can always say the algorithms.
Sorry, you really need to
Sure.
to speak
Okay.
louder and a bit
as,
slower if you
as part of the long-term authentication, the server throws an error and it can always indicate the algorithms that it supports, and then the client can pick one of them, right?
No, this is not how we do things in this case. The server support both. Currently, a server which is implementing this draft is supporting the old the message integrity and message integrity 256, both. Okay, and the client, depending if it's an old client or a new client, respond with one of the other. And this is how the server knows what version it should continue to use. There is no negotiation in this case. And the plan, which was put in place in RFC 5389, is that later in the future, a new draft will deprecate completely message integrity. And then if we go to SHA-3 one day, then we will do the same thing. We will add a new one.
But I don't really see a need for sending two message integrities, right? I mean, if you're doing an authentication, the server can indicate the algorithm it supports and the client can pick whatever it wants to pick, right? Why should it sign with both the have HMAC values computed using two algorithms? What's the purpose?
What it's to support both clients.
Yeah, but the server can always indicate that to the client, and client can pick what version algorithm it
Well,
supports.
the client can always choose. If a new client decide to do not use, there is no protection in this case.
I mean, I think that for long-term integrity, it should always be possible to know that a server supports.
Yeah.
Basically, if the server does the rest of the things that are involved in long-term integrity, you can know it. For short-term integrity, if you don't have some other previous out-of-band mechanism, you don't necessarily know. For short-term integrity, you'll need to send both, unless you have like some negotiation, something like ICE or something that says,
Yeah.
I know that, I support this.
Yeah,
Yeah, exactly. And we talk about this, that
Yeah.
you can have a negotiation, the SDP, for example, that say, it's a case for ICE, for example, that they probably need a flag to say, okay, this client now always support the new version. In this case, there is no issue. But it's outside.
Yeah, I mean, so Jonathan, I think in most of the actual usages we have in practice, you'll never actually need to send both. Because for term, you won't need to send both. There's always one term, and for ICE, you won't need to send both to negotiate an SDP. And I think those are the only ones we have that actually authenticate. So.
Yeah.
Okay, any other comments or questions? Okay, thank you, Mark. Okay, we will follow up on the list, and whenever you revise the draft and it's ready for working group last call, we will start gathering dedicated reviewers. Okay, thank you. So we have one more presentation today. Okay.
Thank you. I'm the first time to attend the Tram working group, so I will make my best to introduce our solution. So here we call our solution as the operator or the release service architecture. It is compared with the turn service architecture. So our work we work with software together with Huawei and Google company. Here I first explain why we want to propose a new architecture. We have been exploring the service provider might provide turn release service to their customer, mostly the ICP or some application provider. And how do they provide the service? Well, they want to just utilize the already deployed CGN or CDN device. These services are deployed in distributed manner. When couple this function into this device, they want minimal exchange to the existing CDN and CDN device. Another consideration for the new architecture is the SDN technology and architecture are emerging. So we want to use such a concept and architecture to solve the peer-to-peer communication under the net environment. We found it was complex when we use the current turn solution, because in current turn solution, every turn server must resolve and plan the relay address and port to every host. So because these devices are distributed, so this is a big burden for the SP if they want to use the distributed device to provide the service. It's best, another problem that we consider is the current turn signaling complex. It is based on ICE interaction and use different processing for UDP and TCP communication, and for the V4 and V6 host communication. This is the reason that we want to provide a new solution to the peer-to-peer communication. So next slide. This is our brief architecture. There are mainly three main components. First is the release selection module. The second is the CDN device. It is distributed deployment in the operator network. The last is the client, which is initial connection request. So under this such a architecture, we have the following advantage. The relay device, such as the CGN, CDN, need not allocate different relay address for client, such as done in the turn solution. I will explain this step in next slide more detail. And the signaling procedure are significantly simplified compared with that. And we also, because we use same solution to the TCP, UDP, and V4, V6 communication, in the same architecture. And under such an architecture, we can provide the RESTful service to the IPP provider. Use this architecture, SP can easily integrate the relay function into the distributed device, such as CDN service. And SP can also provide the data relay service to the IP provider via some RESTful interface. Next. This is the communication procedure for to introduce our proposal. let me consider the host 1 and host 2. This is the host 1 and host 2 want to communicate. It is firstly they will register to their IP provider. There is some simulation.
Oh, there's animation.
Yeah.
Yeah.
Okay. First, they will communicate with register to their IP provider, and IP provider will tell them that which IR release selection will service them, and they will get the reflex address to the release service. This is the first step, and the second step is the IPv server will send the reflex RS pair to the RS. Let the release selector to select one operational release device to release their communication data. The selection criteria is just based on the reflex RS pair. It is some distance objection or not. The third step is because the third step. Because the RS have told the client which device will release their communication data, so client can get their reflective address. This address is to reflex relay and report them to RS. Then RS can form couple packet and send it to the select CDN device. Then on the CDN device, there will be match table formed. The last step is client then can send the TCP UDP packet via the select CDN device, use the same relay device, relay address, and the relay device will transport the to parallel connect and then send to another peer. So, okay, next. This is some called difference point between the turn and us. The first is the relay address allocation. So in current turn solution, the turn server will allocate a different relay address for every client. But in our solution, all the communication peer will get the same relay address. This is the big difference. And for TCP and UDP data relay, in current turn, as I have mentioned before, they use a different single procedure and the data transfer procedure. But in us, we use the same single process and the data transfer procedure. The release selection decision in current turn solution, it is done by every client. So each client may select different turn service. But in us, the relay device selection is done by the relay selector. The relay selector has the whole system view, so it can select the most optimal relay device to provide the communication service. And the next thing for finish the communication, the in current turn solution, there at least eight messages needed to finish the communication. But in us, we need mainly two command. The first defined is the stun command, and the couple is the newly defined command. Next, please. So we also consider the relationship with the turn. So also we think is not intended to be a full alternative of turn because they can use in different scenario or different situation. We consider it as a complementary solution for SP public release service. Next. In previous architecture, we just provided the communication procedure in one domain. So if the communication host located in different SP domain, there are two solutions to finish their communication. The first is the APP provider can select one of the RS to finish the relay selection. The second is we can build some tunnel, build some tunnel between the two relay devices, and to lend the tunnel to transfer the communication data between two hosts. And the detailed procedure will be provided in full version of this draft. So this is our brief introduction to the new solution. Thank you.
So do we have any comments or input about this draft?
Yeah, thanks. Two things. First of all, this only works for, I guess, a WebRTC style model where there's a single application provider. It wouldn't work for a SIP style model where you have independent endpoints communicating with each other, because in that case, there is no app provider as such.
I think it, if the IPv has a server, I think it is suitable for.
Yeah, so I mean, in the SIP model, there is no single central server. There's just clients and their own proxies, but they look at each other. And then the other thing is that this relay can only be allocated once you know both endpoints that are communicating, right? So both sides have to send up their binding and and do whatever that message was, the couple message. They both have to have presumably some sort of unique token which is shared between them.
Both clients need only send the bind message to the relay device. The couple message is sent from the relay selection to the relay device. So.
Yeah, so I mean, so something like SIP forking, this wouldn't work, or you'd have to have separate couplings or something. Coupling per fork. Actually, can you go back to that minute? I just want to make sure I understand those.
This one?
No, the previous one. They had the diagram.
Yeah.
Yeah. So, yeah. I mean, so basically, both sides have to send the.
Just the bind message to the relay selection and to CGN just to.
Okay, I see. Yeah.
Because
there still has to be an app provider and there has to be a trust relationship with the app provider, the relay selector, and the CGN.
Yeah. Sorry.
You want me to relay for use? He asks, how would this interact with ICE?
Recognize the different PR.
Yeah, how would this interact with ICE? I mean, if you were to event then with this. I assume what this basically just does is it makes the server reflexive connection work, even if it otherwise wouldn't, right? That's the goal.
I think ICE is just to try the communication address. So I think if the reflect address cannot communicate, then it can use the relay address from the auth. This is the last step.
I'm not sure I quite understood your answer there. Are you saying that is this or ICE, or is there some interaction between them? Does the client make a choice between using this procedure or using ICE? Or does it use some sort of combination?
Currently, we consider only the relay service, do not consider interaction with ICE.
So the question is this an alternative to ICE? So it's ICE, you choose to use ICE or this mechanism?
Yeah.
Or do you use them simultaneously, like combined? So that was the question.
I think this solution can finished independently, and did not depend on ICE.
So instead of ICE, you would use this.
Yeah.
Okay.
Because the host can get all its address, the local address, reflex address, and the address. It is can get the same content as ICE. So
What is your answer? If you're not using eyes, but I still have to find my reflexive address before in bullet 1, how do I find that? Using stun or this?
when host gets one host, two hosts want to communicate, they also to this, the IP provider will know which pair will communicate, and each client will report its client address to the IP provider. So we can exchange the reflex address via the IP provider.
I'm curious because, I mean, with ICE, we're trying to find the best media path for two. We could have dual stacks, we could have single stacks, we could have server reflexive, and we could have relay addresses. But it seems to me that you're trying to force a relay into every communication. That's what we're trying to do. So there's no options. We should use a carrier app relay. Communication path.
We're gonna need to wrap up because they have another session in 2 minutes. So, so you got some useful feedback, some questions. So please take it to the list and continue discussion there.
I will consider the relationship with ICE.
Yeah, consider all the feedback you received and clarify that, and get back to the list. That'd be great.
Thank you.
Yeah, thank you very much. Okay, any other business before we close the meeting? Okay, so thanks for coming. The meeting's over.